There's a couple of new videos out. One is on the solving the hard problem of physics and consciousness. I just wanted to share a particular comment from YouTube and one of Tom's quotes. I like Tom Campbell's theory. All he is saying is that consciousness originates from outside the universe instead of inside. This consciousness evolved and became so advanced that it could run simulations, and this universe is just one of them. That can't be too hard to understand. After all, we run all kinds of computer simulations ourselves. This is from one of the comments on YouTube, and I remember Tom saying, the people will drag the scientists kicking and screaming into the next paradigm, and I think that applies here. I just thought it was a nice positive comment, and I wish more of the scientists would think along those lines. The first question is about individuated units of consciousness and choosing an avatar. I'm going to bring this up first because a video out there, how consciousness connects to the avatar. That's something that we just did recently. The question is by Shaw. You've mentioned that individuated units of consciousness choose an avatar based on what will have the highest probability to lower their entropy in the next virtual reality incarnation. My question is, since individuated units of consciousness don't have free will or personalities, isn't it up to the free will awareness unit within the PMR to determine what avatars are available?
Well, I'm not sure I agree with the assumptions that are in the question. The idea that individuated units of consciousness don't have free will or personality, I'd say that's not the case. They exist within their own virtual reality worldview. And, you know, virtual realities can be nested. You can have a virtual reality inside a virtual reality inside a virtual reality. So that, I think, is a problem to begin with. Now, you have to realize that virtual reality can be a very simple thing. The very first virtual reality was just a communications protocols. How do we communicate with each other? Language. Okay. Virtual reality is just a rule set that produces what? Context, continuity, and a way that people can share. In other words, common language, common structures that we can use to communicate with. That requires rules. And any place you have a rule set and everybody inside a given system that abides by that rule set, then they're part of a virtual reality. That's what virtual reality is. It's we interact according to rules. So we have our PMR, which is a virtual reality, and we have a rule set. And the rule set is our science, our physics, at least is a subset of that rule set that we've dug out. And our avatar, our physical body, has to abide by that rule set. Okay, that we can only think so fast, jump so high, and whatever else, because that's the rule set. We get diseases. You know, we have babies. We do all the things we do because that is the natural evolution of that rule set, based on you know, on how it has in the past evolved to become. So the individuated unit of consciousness, being the function of the collector of various incarnations or experience packets, it collects all that information, but it itself can interact, can communicate, and is part of a larger virtual reality. So I wouldn't give it the idea that it's not, that it doesn't have free will and it doesn't have a personality or anything. It just is the collector function. I think maybe from your question, you're taking these various metaphors too seriously. When we talk about an individuated unit of consciousness, a free will awareness unit, you know, even the larger consciousness system, higher self, all these things are metaphors. Don't take them too literally. When you start thinking of them in terms of, you know, quasi-physical things, and really you're thinking of them in terms of physical things, because that's the way we think of everything, because that's just the way our minds work from being in this virtual reality. You begin to see them as individual boxes of, individual things. Okay, now you have this thing, and it's called the individuated unit of consciousness, or perhaps the higher self, or something else. And now you put that in that pigeonhole, and now you have another thing, and it's the free will awareness unit, and it has certain functions and things it does. That's in another. Now you have to draw lines between them and how they're connected and how they communicate and which one does what to who. And you're creating all of the structure around metaphors that were basically just created to describe function. Okay, we see that consciousness has to have certain functions, and the accumulation of all of this learning and growth and entropy reduction needs to be accumulated. I mean, that's the whole point. That's why we're going round and round in this game, is because we're accumulating a lower entropy, a higher quality consciousness. So if you're going to learning is based on a series of steps. You have to have an accumulation function, or you don't learn. If you don't accumulate, if you don't have memory, if you don't keep adding to it, then it never goes anywhere. So we have a function that's the accumulator function, and we'll call that the individuated unit of consciousness. And then we have a function that actually gets completely absorbed in this virtual reality we call PMR, and basically is the player for the avatar that is our body. And we call that the free will awareness unit, because it's exercising free will inside this virtual reality that we call home. Okay, now those are functions. You also have to have an executive function. Who produces this virtual reality? How did it come to evolve? Who originated with the initial conditions and did the experiments that got the right initial conditions that would create a stable virtual reality through evolution? Well, we call that function, that executive function that's kind of in charge and is the manager. We call that the larger consciousness system. You see, so we have functions that the My Big Toe theory lays this stuff out, and in order to be logically consistent, there's certain functions that have to be performed. Then we give those functions names. That's how metaphors work. Okay, now don't try to make them into solid physical things, because then you have to do, when we have physical things, we need to draw lines between them and know, how do they communicate? Oh, we have, my house and your house. How are we going to talk? Well, we could talk with cell phones, or we could talk over landlines, or we could send mail, snail mail back and forth. There are all sorts of ways, but each one has a mechanism, a process, and certain rules that allow that, and we kind of see it as separate things, and the wiring between them that connect them. Well, now we have metaphors that describe functions, and you kind of have to let it go at that, because the details of how they're wired or connected, or exactly who does what to who, isn't really important, because unless it's a fundamental function that we have to deal with, then it's just kind of lost in the details and isn't a very important thing. It falls in the box of inquiring egos would like to know. It's not any part of the fundamental processes that we're trying to describe. So I'm sure there's lots of details that we don't understand. In other words, we can't directly experience the thing itself, this consciousness thing. We don't directly experience it. We experience the data. The data is not the source of the data. The data comes from a source. We don't experience the source. We experience the data, and we interpret the data. And that's what we are as consciousness. It's an information system. So we just have to look at the functions that make the whole thing logical and make it work, and not get too carried away with the details of how exactly that works. So I guess I didn't answer your question, but maybe I did in an off-center, kind of a sideways way. And that is, some of your assumptions that led to the question, I think were not good assumptions. So then it's hard to answer a question like that. If the assumptions leading up to the question have problems, then you have an answer that has problems. So go ahead and ask that again when Donna gets done and kind of has free space, or maybe you want to allow it now to see whether or not you want to rephrase the question, or whether I'm off the mark from the answer.
Okay, well, there are some more questions on the individuated unit of consciousness, so we'll move on. Shaw asks, again, Ted mentioned something about individuated units of consciousness having a sort of personality type, similar to the Myers-Briggs Keirsey personality types, even though they don't have an actual personality. My actual question is, what determines a personality type for these IUOCs? Are they all created exactly the same and only develop a personality type based off of random early experiences within virtual reality? And do IUOCs have personality types based on a system of evolution and what's needed at the time?
Okay, now let's start with the more fundamental question: was, are they all the same? And the answer would be, I wouldn't think so. No, that wouldn't. That certainly would not be a requirement. Are many of them similar? Probably so, because there's only a certain amount of range that makes a functional, individuated unit of consciousness. So we probably expect similarity, but we don't expect them to be the same. I had some similar questions not too long ago about IUOCs, like where do they come from? How do they get created, and where are they? Well, they are just subsets. Again, you see, it sounds vague, but that's because vague is all we need. The details are not important. If we try to make too many details, we'll just convince ourselves of something that isn't necessarily true. So we need to stay at a level in which, the logic makes sense and not kind of dig too much below that. Anyway, they are just subsets, of course, of the larger consciousness system. Now, how did this come about? Well, you have the virtual reality, and then the virtual reality evolves. It evolves, and at first, it's just a virtual reality that has, what should we call them? Computer characters in it, NPCs, non-player characters, right? Because it's just evolving. It hasn't gotten to the point that there's characters that consciousness can play, right? It's a ball of plasma, no characters in that people can play. And then it's a forming universe, no characters in that yet that people can play. And so it continues to evolve, and eventually we end up, say, with a planet like ours, and we end up with cells and biology and life starting to form. And there's still really no avatars there for consciousness to play with. So it keeps on evolving up. And eventually we have things evolve that would, in this simulation, have decision space. Okay, they're interacting according to the rule set. But all the decisions are being made by the big computer. You see, so it's still all just a simulation. We don't have any consciousness playing avatars just yet because, the level of decision space is so tiny, it's not really too interesting to many individuated units of consciousness. And you can imagine that there were lots of individuated unit of consciousness that didn't have virtual realities, that were interacting and communicating before this concept of virtual reality was made, before the simulation became stable, before there were these avatars that then they could go play in this virtual reality trainer. So, and it probably existed on all levels, some with very small decision space and some with much larger decision space. Some had evolved more and some had evolved less. Some of them started probably different places. This is, it's not a cookie cutter where everything comes out exactly alike. Well, early on, maybe the ones that had very small decision space decided they could become players of the things in this virtual reality that had small decision space, and that would be fun and maybe productive for them to do that. And then eventually, when we had mammals and critters with more and more decision space, well, more and more IUOCs got into the game and said, all right, that looks like an interesting character that would have some challenge, and so on. And then eventually you come to a point like where we are now, where virtually all the characters that are being played consistently are IUOCs playing all the characters. But it started out that all the characters were basically being played by the computer. They were all non-player characters. And then as the simulation got more advanced, as you had entities from the rule set that had more decision space, then players started to come into the game, kind of sign up at a level that was interesting to them, and so on it goes. Okay. So it starts small and it grows big. You know, in the beginning, there weren't that many humans on this planet. If you go back 2 million years, when the species was just getting started a few million years ago, it wasn't like there were 7 billion of us running around that all needed IUOCs. It started a rather small scale thing. Most of the IUCs before that must have been in critters of some sort of decision space, or they were NPCs. So anyway, that's kind of an idea of where it all starts and how we end up with these bodies, these avatars that we play with. Now I kind of got off on that tangent as a background, but tell me, what was the question again, Donna? Make sure that I've covered it.
Did units of consciousness have personality type? Oh, sorry.
Yeah, okay,
Thank you, Oliver.
Yeah, where the personalities come from? I got it now. Where the personalities come from? Okay, so we have various kinds of IUOCs starting at various levels. See, in the beginning, so it's not uniform at all, and they start at various times, various levels, various places as this virtual reality simulation is still evolving, still creating new avatars, if you will, because it's still in the evolution phase. And a million years from now, I'm sure there will be all sorts of new avatars that there aren't here on this planet right now. So as that happens, different kinds of IUOCs that have it at different levels. And once they get in the game, if they are like us, it's not just a one-time shot. They stay in the game and they go around and around through different experience packets, learning and growing and using this game as a way to evolve themselves more efficiently. Those personalities then develop out of their experience. So they started in a whole range of various levels and types, and then all of those various levels and types grow and become, and some move from one species to another. The consciousness may move from one species to another, and some don't. Some just start in the middle. Everybody doesn't have to start as a bumblebee and then try to become a dolphin or a human. It doesn't work that way. There is mobility. Everybody has free will, and you can grow and evolve as much as you can. And when you no longer have challenging decision space to deal with, you can bump up to something more challenging. So that's like that. But it doesn't mean that it all started with insects and insects eventually grew into human beings. It's not that sort of thing. It was populated at all the levels as those levels became available by IUCs that had been around for a long time before the virtual reality, ever got cranking away in the big computer. So the personalities basically grow with the IUOC, and it's an accumulation of all of the experiences they have. Now, all of those experiences they have cover maybe 1,000 lifetimes. That's a lot of experience. But we are in, our individual self, us here on the planet, we work the same way. Our personalities tend to be, one, what we come in with, what we start with, and then what we add to that in this experience. So same with them. Wherever they were when they got involved in this virtual reality, that's what they come in with. And after that, it's the experiences they have while they're here. So eventually they just become a conglomerate of all that experience, just as we age, become a conglomerate of all our experience. It's not very different that way. So they do have personalities, and they do grow, and they do try to manage their portfolio of experiences, if you will, and gain as much out of it as they can. But their connection to this particular virtual reality is as a subset that we call the free will awareness unit. They are the integrator of all of that. So it's just like we have various roles here. We have, we can break it up like that. We have our role at work, our role at home, our role with extended family, and all of those roles that we play are a little different. But all of that experience, even though we kind of act a little differently in all those situations, All those experiences combine into us to make one whole person. And this is sort of like that with the IUOCs. So I hope that kind of answers your question about the IUOCs, their personalities, what they do. So they may have a life of their own in the sense that they may be communicating with other IUOCs. They're still on the network. They're still in a virtual reality. And at the same time, they're gathering experience from all of their experience packets, that they have that going on as well. And the reason they do that is that the experience you get in this experience packet in PMR is so much more productive because of all the feedback, and all of the rule set creates strong context from which the experience can make sense, from which you can get meaning from the experience. That's why it's so valuable to have a part of themselves in a virtual reality all the time, because that's where most of the learning is going to come from, because that's where the feedback, that's where the connection is, that's where you actually get the results of what you are when you interact with something.
Okay, Tom, we're going to go to Mike's question next, which he's typed in here, and I hope I can read it correctly. His question is related to which way path information. One of the most important findings is that the quantum to classical transition occurs when there is potential which path information, whether or not someone observes the information and whether or not there is a specific detector for it. A common expression is that the information is available in principle. For example, if individual photons, light particles, are sent one at a time through a screen with two slits, an interference pattern will occur, indicating a quantum superposition. It's the same thing as the double slit. I'm not sure. If plates that alter light polarization are placed in front of the slits, the photons from the different slits will have different polarizations that could be detected by an appropriate device to indicate which slit a photon passed through. The presence of the polarizing plates eliminates the quantum superposition associated interference pattern. This occurs even if there is no detector to measure the polarization to identify which slit a photon actually passed through, and thus no observation of the which path information. Note that the light polarization indicates the path of the particle.
Yeah, what Mike's saying, that confused a lot of people who were listening, is that there is an experiment that has created a fair amount of confusion because the causality of what's causing what is confused. A double slit experiment was done, and they put a polarizer behind one of the slits. Okay, so this is just normal double slit. A polarizer, what it does is it changes the direction at which the electromagnetic wave oscillates. What it really does is it filters out all the directions but one. Okay, it lets one direction through and the rest of them get filtered out. All right. Now, a polarizer, it works on waves, okay? A polarizer doesn't work on particles. If you send a particle through a polarizer, well, what does it do? If it either gets absorbed by the polarizing material or punches a hole in it, right? That's a particle. So polarizers are just for waves. It's a wave phenomena thing. Now, as it turns out, we do have waves going through there, not particles. We have probability waves, and the waves of the probability waves interact just like any waves. They have to do that. Otherwise, at the interface, the boundary conditions between waves and particles, it would be a mismatch. But to make that a nice continuous match, we have probability waves that interact like waves. Now, the idea of this experiment was that you would put this polarizer up, and then theoretically, you now have a difference in which way information, because one is polarized, the other isn't. So there is a potential for somebody at that point to go in and measure the polarization, and they'd say, oh, this one's vertical and this one's horizontal polarization. Therefore, we changed the vertical to horizontal down here, and now we know that because it's horizontal, polarization had to come through the bottom slit. Therefore, you've got which way information. And if it's not polarized, it had to go through the top slit. So you have this which way information that is potentially available. But It's not measured. Nobody goes in and measured it. Okay, now what they find out is that when they do that, okay, the interference pattern goes away. Okay, they don't have an interference pattern anymore when they put the polarizer in there. So that makes it look like it's a particle. Now the point was that no information was ever collected. It was just potentially identifiable by its polarization. So the wrong inference is made that says that, well, we just had information available, but even though the information was available, you see, it still got a particle, it still got a particle wave, even though nobody measured the information. So the idea is to say that just having the information available isn't enough, because here you had it available and it still acted as a particle. Let's see if I'm getting there. I'm trying to keep all this straight in my head. The point is, it has nothing to do with information or which way information that the interference pattern is broken. It simply has to do with you've changed the probability. When you put a polarizer in front of one of those paths, you have changed the probability wave. The probability wave going through the polarizer is now modified. It cannot combine with the probability wave that went through the other slit because the polarization is wrong. So it's a simple polarization scheme. It has nothing to do with which way information. Whether the which way information was measured or not measured, available or not, is totally irrelevant to the problem. You've got one probability wave that has no polarization and the other one that does. They can't interfere with each other in order to make a nice diffraction pattern. Okay, so you've ruined that. So you don't get a diffraction pattern because the interference doesn't work. You have two different kinds of waves now. You got one oscillating in vertical direction, say one oscillating in a horizontal direction. You see, they don't interact. So that's what's going on. The which way information has nothing to do with it whatsoever. It is true that if you have available which way information, in other words, there is information that's available to people to look at, okay, something that would create a discontinuity. If I've got which way information and it says a particle went through this slit, then I have to get a particle behind that slit because I've got information that I've measured that said a particle went through the slit. If it said a particle went through the slit and then I get a diffraction pattern, that's a problem. That is we've got a discontinuity in the reality here. I've got measured data that says it's one way and yet it comes out another way. The reality doesn't work like that. So if you have available information that says it's a particle, you will get a particle result. If you have no information available that says that it was a particle, you'll get a diffraction pattern. Okay. Now, if you stick a polarizer, so you change the probability wave coming through one slit, well, now you've just changed the experiment. It's not the normal double slit experiment anymore. Now you've interfered with the way the experiment works, and what's going to happen is you're not going to be able to get a diffraction pattern then because you have polarized the probability wave coming through one slit. You see, the reason people get confused, they attribute the fact that you no longer have a diffraction pattern, that this information was available. It was available, but nobody measured it. And that's not the cause of the loss of the diffraction pattern. The cause of the loss of the diffraction pattern is that the polarizer interferes with one half of the experiment, changes it, and you won't get the two equal things, with the superposition of the waves canceling at some places and adding at other places, which is why you get a diffraction pattern. That won't happen if you don't have two waves that are the same. You've changed one of them. So the superposition doesn't work anymore, and it doesn't have anything to do with whether there's information that is available or not available, or theoretically available but not measured. None of that's irrelevant. It's like if you took a piece of if you took a piece of wood and covered up one slit with it, and then said that, wow, that really messes up the diffraction pattern, and there wasn't any information available, well, you've messed with the experiment. Of course, it's going to change the results you have. It has nothing to do with whether information's available or not. You've just changed the experiment. So that's what's going on there. And people did that, saw the result, mistakenly, said that it had something to do with the which way information, was available, but yet, there it was available. We just didn't measure it. It was available, but look, we didn't get the diffraction pattern. So you see here, you have available information, but still get a diffraction pattern. Oh, you guys don't know what you're talking about. Well, that's because they got they misunderstood what was causing what. The polarizer changes the experiment. Which way information is irrelevant. You nail a board across one of the slits, you can't blame that on which way information. You've just changed the experiment. You see, that doesn't have anything to do with which way information. You've taken one part of the experiment and modified it, and now you're claiming that, the experiment didn't work like it did before. Well, of course it doesn't work like it did before. You put a polarizer in one of the things. You hammered a board across one of the slits. It doesn't work the same anymore. That's not surprising. So that's why it's just a misunderstanding. It was done. I think there was even papers published because the people didn't realize that they had the wrong causality, and they thought they had something major. Other papers came out later and said that's nonsense. It's this polarization problem. It doesn't have anything to do with information.
So it's documented?
Yes, I've read that someplace. Matter of fact, it's Claudio that brought all this up, and interesting enough, Claudio, who has sent me all kinds of papers over the last 4 or 5 years, saying, look, these people, have this and this, and of course, Claudio's not a physicist. He can't read the papers. He doesn't understand them, but he sends them to me thinking that I will maybe see this problem. And I looked through the papers, and one of them was a paper that said, 5 or 6, 7 of the major misunderstandings in quantum mechanics theory are about the double slit or something. And in there indeed was one paper that took to task this idea of the polarization and said that was a lot of rubbish. Polarization wasn't really polarization changed the experiment. So yes, that's documented and it's fairly well known. But now people have a wrong idea about physics and physicists. And if they talk to people in any other complex and technical field, they'd find it was the same way. But you'll talk to physicists, and you can probably find 1,000 of them if you look hard, that will tell you that the reason the double slit experiment works the way it does is because of the interaction energy exchange between the detector and the particle. And they'll say that. And they're physicists, and they have PhDs. They just don't know. I just had somebody...
if just because you have a PhD doesn't mean that you're understanding it properly.
Exactly.
I've kind of avoided this whole thing because I've never really found it interesting. And I'm sure that you are so excited to talk about this again for the 14,000th time.
Mm-hmm.
But, I delved into it, and I was chatting with Justin just the other day, and it's like I've gotten this crash course in online PhD in physics that I've been going through to try to finally say, what, let me dig into this and see, because I've just wanted to figure it out. And going through it all, there is so much room for confusion and convolution where you can play this who's on first game back and forth and back and forth and back and forth. But basically what you're saying is, and the crux of my question is that particular experiment is not the same.
No, it's a different experiment.
Like the DCQE experiment. However, right. Would I be accurate? It doesn't prove you right or wrong technically in as far as the regular, let's say, the envelope double slit experiment.
No, that experiment really has nothing to do with with the double slit experiment. That's a polarization experiment. Take a pair of polarized sunglasses and take the lenses out of them and hold one up to the light, and the light gets dimmer. That's why it's a sunglass, because you're filtering out a certain amount of the light because it's not polarized. You're only letting vertical polarized light through. Then you hold up the other sunglass and you rotate it 90 degrees, and now it's black. You don't get anything through it.
No, I get it.
That's a polarization experiment. Now, if you take one of those polarized sunglasses, put it behind one slit, take the other one, turn it 90 degrees, and put it behind the other slit, you see, they can't possibly interact with each other because they don't have the same polarization anymore. You got two different waves going that are of different types, and this rule of superposition where you have these waves going, and the peaks happen together, or both the dips happen together, and they add and subtract. You don't get that when you've mangled one side of the experiment. And then the mistake was to think that had something to do with the superposition of quantum states and the possibilities of information existing. And all it has to do with is you've changed the experiment. It doesn't work anymore. It doesn't work.
So does it? Would the results at D1 and D2 in the double DCQE experiment, would it doesn't prove one way, that does it suggest that you may be right in theory based on D1 and D2? I mean, it actually doesn't prove you wrong, but it actually suggests based on D1 and D2 that results indicate that your theory may in fact be correct, because it's not proven wrong at all.
Absolutely right. You see, that theory, now people listening to this won't know what D1, D2 is, and there's a in 1999, the work was done, published in year 2000, and it was a major double slit experiment.
It's a brilliant experiment, but I think
it was a really good experiment. Right. And what happens is it was a delayed erasure experiment. So what they did is and it also was a touchless. There was absolutely no energy touched the particle in order to detect what slit it went through. You see, so they decoupled this. Oh, it's the energy of the detector that has to interact with the particle in order to detect it. And anytime you detect a particle, that has to be an interaction between the energy of detection and the particle, and that's what causes this the way the double slit works. Well, people a long time ago, back in the 1920s, said nonsense. That energy exchange is too small to do anything. It doesn't have anything to do with it. But because there are a lot of people who really, really want this double slit experiment to conform to objective materialism, they have had this knowledge in their little hearts that there must be some materialistic objective explanation. And they clung to the idea that it was the energy of interaction between the detector and the particle. So that became a kind of a standard. That must be what's going on because that makes good objective material sense, right? We know that must be going on, even though the analysis of it said that's not what's going on. But, believers will cling to their beliefs in the face of facts. That's just the way believers are. So that went on for now 80 years, or not 80 years, probably 70 years at that time. And back in the year 2000, these guys came up with a very clever experiment that said this is touchless. We have a way of determining which way information that never touches the particle. There is no energy that reaches out and touches the particle. They made entangled pairs, and they could get the which way information from one set of entangled pairs, and then they could actually collect the data on the screen from the other set. Okay, and they didn't do anything to those entangled pairs other than detect them. So it's not like they did something and the entanglement would send that message back up to the other particle. All they did was detect them. So it was a very elegant experiment. And it was doubly elegant because not only did they show that the detector energy interacting with the particle had nothing to do with it because there was none, but they also made it a delayed erasure experiment to where they collected the data, the which way data, and they erased the which way data after, and in times of particles, long after the information was collected on the screen.
At D0.
Yeah, and that's in D0. So we had these particles went through two slits. You had the probability going through both slits. The probability interacted with each other, and it goes to the screen. The screen captures the data. That part of the experiment is over. The actual collected data of the experiment is done. Now, later, we come up with a measurement of which slit the particles went through if it ends up in what, D3 and D4. Okay, later, after the data has already been taken, I say, aha, it went through, you know, the bottom slit, that's D4, or went through the top slit, that's D3, you see? And then even later yet, in some cases, it didn't go to D3 and D4. We didn't get this, it went another path where it gets confused as to which way it would have gone. We don't have any information because it could have gone into D1 or it could have gone into D2, and it's equal probability. We don't have any idea which slit it went through. Basically, the which way information is now erased and gone. Then what they did is they threw lots of particles through this thing, and they, by using time, they associated the results they got on the screen with the times that later produced a D3, D4. In other words, where they had which way information. Again, the which way information occurred after the experiment was over as far as collecting the data goes. Okay, so then whenever a particle, after the data had already been collected, happened to produce which way information, guess what? That data that had already been collected just happened to fall into two piles behind each slit. And then those particles where no which way data was collected because it was erased, all of those particles, doubly long after the data had already been collected, had a diffraction pattern.
Magically. It just,
yes,
just
you see,
magically
and now,
agrees with you. Magically.
Yes. Now, what happens is what that says is that if you have information available, you'll get two piles of particles behind each slit. If you don't, you'll get a diffraction pattern. Now, okay, their delay time was like 10 nanoseconds or something. But in the world of these particles, that's a long time. But the time is not a variable. You see, it doesn't matter whether it's 10 nanoseconds or 10 years. It'll all work the same way. Whether it's a short time or a long time, if you can take the signal, the signal particles and you collect them, they're on the screen, you've got your data, then sometime later you decide whether you have which way data or whether you don't. And all the times that sometime later you got which way data, those particles just happen to end up in piles behind the slits. And all the times when later that which way data got erased and confused where it may have come from, all of those particles just happen to end up in diffraction patterns, you see. So that is exactly what my theory would predict.
Right.
That's exactly what would happen, you see, because the time is not a variable, doesn't matter how long. So in my little experiment that I make it easier for people to understand, that little experiment where we do the envelopes, you know, and we wait a year or something and we come back. Well, what I'm doing is just making something that's simple and straightforward to understand instead of D1 and D2 and zeros and time correlators and all that kind of stuff, which confuses a lot of people. It makes it really simple. But the same things are there. Again, time, it doesn't matter. It's can come a year or a decade later. What matters is the fact is that the answer, what's on the screen, is just probability. You see, that probability, that wave function, if you will, doesn't collapse because it hits something. See, we've got this materialistic idea, oh, there's a wave and it hits the screen and the screen makes it collapse. It collapses because somebody looks at it. Until somebody actually looks and sees what that data is, it's still just probability. It's not magic. It's the Schrodinger's cat, right? It's the same thing. It's just probability. And this is not like Tom Campbell's weird idea of quantum mechanics. What I'm telling you is what has been called for 80 years the Copenhagen interpretation. It's the fundamental interpretation of quantum mechanics that's been accepted by most quantum mechanics folks for nearly a century. It's what Bohr and Heisenberg and the rest of those guys that made up that group that met at Copenhagen in the early days in the 1920s and early 1930s, they took all their data and they said, here's what our data is telling us. Okay, so here's our, here's what's going on. Well, that's the same thing I'm saying. So it's not I'm coming out of left field with some weird theory that Tom Campbell thought up one night while he was, out of body. This is for goodness sakes, the Copenhagen interpretation. It's the same thing that's been around for decades. And that was the same Schrodinger cat idea. And that is what's on that screen is still just probability until somebody looks, because this is Tom Campbell's part. The reason that's not just weird mystical science is because we are in a virtual reality and it's run on probability. It's a probabilistic virtual reality. Okay, in a probabilistic virtual reality, you have characters, we'll call them players. They get data from the server, from the computer, all right, that's doing the virtual reality, and they send data back to the server. So here you are playing World of Warcraft. All the action is going on between the consciousness playing the elf and the server. The server sends information to the consciousness sends information back to the server. The server sends information back to the consciousness. You see, the whole game's being played between an information flow between the computer and the player. The elf on the screen on your PC, that's just the data output of the server. That's the information coming back to you. It comes back to you by a bunch of pixels lit up on a screen in front of you. You interpret those pixels to be your elf fighting a barbarian or something. And based on how you interpret them, you send data back to the server. The server then moves the elf, tells the elf to run. That barbarian's too big. So then the server does that because that was your request. You said, I want my elf to run. The server says, okay, your elf is running. And he sends it back and you see your elf running on the screen. So it's just a communication between the consciousness and the server and the computer. Well, our reality works the same. So until the player looks at that data, what's the server to do? There's nothing for it to do, right? It only sends data to players. When there's nobody in World of Warcraft, what's the server doing of World of Warcraft? Nothing. If there's no players, it's got nothing to do. You see? It's a virtual reality. It doesn't have to keep the water flowing in the rivers in the World of Warcraft game and the trees green when nobody's there. You see, there are no rivers, there are no trees. It's just a virtual reality. Well, it's like that here too. So until somebody looks at that data is still just probability. Now, when you dig out information and you say, hey, after the fact, I found out that this went through slit A and the other went through slit B. Well, now you have information here that says what slit. What that does is it changes the probability of what you're going to find in that screen to a 1 for particles, 2 blobs of particles behind each slit. You just change that probability. And then you erase that information. Now you've changed that probability to a 0 for finding particles behind those slits to a 1 for finding a diffraction pattern. You've modified the probability of that result based on what you do. And even if you do it after the experiment's over, it doesn't matter because the results don't actually get sent from the server to the player until the player asks for the data. The player needs the data because the player looks at the screen and sees what's there. The moment the player looks at the screen to see what's there, then the system says, well, what's the probability of what's there? Well, there's information in the system that says it's a particle. Well, damn, that makes it a probability of 1 that what they're going to see is a particle, because otherwise you have information that it was a particle and then not be a particle. That would be a problem. That would be a bad virtual reality where you have data that is inconsistent with each other inside the virtual reality. So that's why it works that way. So what Tom Campbell brings to it is an understanding that takes it from being weird science to being, oh, I see how that works. Sure, it all works that way. And it's not just little things, but why do we think that little thing, oh, that's quantum weirdness for little things. Big things don't work that way, but little things really weird. It's the same thing. It works everywhere, you see. It's the nature of our reality. So when the astronomer looks into outer space, he looks at a piece of space that nobody's ever looked in before. There's a probability of what might be there. And when his telescope takes the picture, something is given to him. He takes a random draw out of the probability distribution, and that's what's there. And now that information is here in this reality, then that's what everybody will see there. Okay, it can't be inconsistent. And that's why if that guy, his telescope and his camera and his picture and he all get burned up that night, well, somebody else looks there the next day. There is no information that's what's there anymore in this reality frame. So another random draw is made from that probability distribution, and might be something different there next time. All right, well, people say, well, that's weird, Well, the only reason it's weird is because you have a belief in this being a material objective reality. It's a cultural belief. No, you didn't have to memorize that. You didn't, sit down and have people brainwash you about it. It just seeps into your mind because you're in this culture, and that's what we believe in this culture. It's a cultural belief. We just suck it up out of the air, out of the cultural ooze. It's in our mind. It's part of the shared consciousness that makes us a culture. Okay, so you believe it so much that when you see that double slit eraser and you say, after the fact, they come up with no which way information, and you get a diffraction pattern, and after the fact they come up with which way information and you get two lumps of particles behind the slits, that's impossible because they collected that data before either of those took place. You mean the data changes? It was one and the data then will change to the other one depending on what you do? No, nothing changes. The cat in the box in Schrodinger's is neither dead nor alive until you look.
It's almost like this is the last line of defense for reality, like the device that could possibly, the question I had about potentiality, or literal information, but if there is a potential to go back, and reverse somehow, there's some mechanism that could go back and reverse and figure out after the fact if there was information that could tell you which slit it did go through, even though that's not technically, I would say, not in this particular reality frame, but it's potentially obtainable, recordable information in this reality frame. You would agree with that, right?
Well, you'd have to be able to record it. Let's put it this way: when I did that kind of thought experiment to make the concepts easy with the envelopes. Okay, I had envelopes, right? And I had all the double slit experiments were done 102 times, I believe, as I recall, and they were all done with detectors, with detector information, and so on. So everyone had detector information. Everyone was done. It was all collected, you see. But then we shuffle those envelopes, and we randomly take half of them, and without looking at the screen, we just pull out there was two envelopes inside the big envelope, 102 envelopes, but each envelope had two envelopes in it. One was detector data, another was screen data. So we pull out in half of them the detector data, and we burn it. Now, there no longer is detector data there, right? So it's still just probability what's on that screen. See, nobody's looked at that screen data yet, so that's just probability. And before we burned it, there was a probability of 1 that it would be particle data. Because there's particle data there on that screen, you see, we did that experiment. Once we burn it, there is no such information, so we get a diffraction pattern. But now let's say that instead of that, we don't burn it, we just leave it, and we open an envelope, and instead of looking at detector data first, we look at the screen data first. All right, we look at the screen data, and we see that there is 2 blobs of particles behind each slit. Okay, now why is that? We've never looked at the detector data, so why couldn't it be anything, right? Well, no, it's not like that. We have detector data sitting right there in the envelope. The fact that it's available means we're going to get 2 piles of electrons behind each slit. It's available to us. All we have to do is open the envelope. So it doesn't matter whether we ever open that envelope on that detector data. We always could open it. You see? We always could open it. So
it's just as I was reviewing through it all, maybe the fact that I don't have all this extensive training and conditioning through all the physics universities and everything, when I saw it, and I even reviewing the DCQE experiment, it was so evident to me. It was like D1 and D2 is basically suggesting Tom is right, and it was so obvious to me. Based on that, just that alone. And then, it seems that there's a lot of mincing of words of all different types of people's, explanations of what does possibility mean? What does this mean? What does that mean? The bottom line is your particular experiment has never been done. So no one can say that it's not true until it's actually done. What I would like to do is somehow put together maybe we can raise some funds or put some pressure on some of these, highly profiled people, because some have suggested that if you are correct, if that is which basically the T1 and T2 does prove, suggests, then it's possible that you can travel faster than the speed of light. What do you think? What do you say to
that? Possible. I'd say that anything's possible. Almost anything's possible. But I'd say that that's also highly unlikely. So I don't like the possible word. Yeah, anything's possible. But no, I don't think that's likely. And I don't think one leads to the other. You see, they are
erroneous.
That's more nonsense. What they're thinking is that they're believing in magic. They think that what happens is that when the delayed eraser happens, somehow what's on that screen changes to be the way the information you collect later is. But the change is so fast, it's instantaneous. Oh, hey, well, maybe we could use that to go faster than light. You see, it's not changing. That's another wrong idea about it. That doesn't have anything to do with going faster than light. That's not what's going on. They still don't understand the basic idea that this is probability. Now, Bohr and Heisenberg, they didn't understand this was a virtual reality either, but they understood their experiments, and they said, this is what the experiments are telling us.
At least
what happened? Yeah, they accepted that and said, this is what it is. We've done these experiments. They did their eraser experiments. They did all this stuff already. This is almost 100 years old. They cut the conclusions and said, here's what it is. This is all probability. And everything stays in a suspended state of possibility, according to the probabilities, when the data gets looked at. They didn't understand a virtual reality, but you see it fits. The virtual reality, just fits it like a glove. So that's a good idea. That's another point that the virtual reality idea is probably right, because it fits the data perfectly. You see, now what happened then is that a lot of physicists looked at that and they said, it doesn't make any sense. We don't want that. We want something else. And they came up with an alternative way of doing business. Their alternative way of doing business was to just call that weird physics and go on. And they decided that they would create reality out of particles. It would be a particle description. Particles would do everything. Particles were at the base of it all. And of course, they realized that that wouldn't work, because particles don't turn into waves to go through two slits at once, you see. So they realized that wouldn't work. So then they said, well, okay, they're just weird particles. You see, they're so small that they're just these strange quantum particles that have these strange ways of pretending that they're probability, but believe me, they're particles just the same. Okay, they're quantum particles. Well, just having the word particles in the phrase made them feel better. And they've been clinging to that particle theory ever since. And there are a lot of physicists that still will tell you that the double slit works the way it does because of the energy hitting, the particles from the detectors. Not true. Others will tell you this thing about this polarization stuff. Not true. All of that is nonsense. There are a lot of physicists in the world that don't really understand quantum mechanics. After all, listen to Feynman. Feynman was one of the best, a very smart guy. Quantum theory was his field of a lifetime. He rose to the top of it. Quote from Feynman, "I don't understand quantum mechanics." End quote. All right. Now, Feynman said
he couldn't see the virtual reality aspect. Is that
right? That's because in his day, virtual reality was just not a concept. You go back 10, he died now probably 20 years ago or so. Virtual reality was not a big idea. It wasn't something, certainly my work wasn't out yet. And maybe he's been dead for 25 or 30 years. I don't know. But virtual reality was not a major idea accepted by scientists. Now it is. Had Feynman been around now, when you have people talking about virtual reality in all the major universities, and it's a serious thing to talk about, he may have come to that conclusion that it made great sense for him, but he didn't, he didn't last that long. But here's Feynman, you know, the top of the top, he says, I don't understand quantum mechanics. Nobody understands quantum mechanics. It just doesn't make any sense. And then he says, if we ever understood that double slit experiment, that holds the key to the whole ball of wax. That's, you know, if we understood that, we'd understand the whole thing. Okay, now that's Feynman, you know, so he's also the one that said, shut up and calculate, where he's talking to his graduate students. Well, Feynman, why does it work this way? Shut up and calculate. I don't know. I don't understand quantum mechanics, you know. I'm just the top quantum mechanics theorist on the planet, but I don't understand it. Well, what happens, he could have understood it if Bohr and Heisenberg and the rest of them had decided to then investigate this concept of a reality based on probability. They may have eventually then, their logic would have taken them to virtual reality and other things. But instead they said, that doesn't feel good, I don't like it. These are going to be particles. Uh-oh, particles don't go through two slits at the same time, so they're funny particles. They're quantum particles, and everybody knows in the quantum world, particles are funny. They just do strange things and we don't understand. So from then on, we saved our belief in material objectivity. So we could cling to Newton's idea about reality, which is objective reality, you know, material reality. We didn't have to let that go into some kind of woo-woo probability reality that nobody liked, and people have been clinging to it since. That's why so many physicists will tell you it's the energy that hits the particle is the problem, and they'll tell you all sorts of things, but most of them don't really get it until they get to Feynman's level, and then if they're honest, they say, I don't understand it. You see, but all of these people that you know, you talk, oh, here's a physicist, and he says, oh yeah, it couldn't possibly work like that. That doesn't make any sense. That's just another person who is sure in his bottom of his little heart that this is an objective material reality and he can't see it any other way. And a whole lot of physicists fit into that. Eventually, if they get good enough in quantum mechanics theory, they say the same thing Feynman said. They say, I don't understand it.
If they're honest.
Yeah, if they're honest. See, now all these physicists that you know, you hear you know, quoted, and the things they say, well, they haven't gotten up to Feynman's level yet, and they believe they do understand it. And by God, it is materialistic, and it does make sense, and it is that energy doing it. And it couldn't possibly work that way because we know physics isn't magic. You can't change what's on the screen after it already happened. You know, that's backward causality, and wow, this stuff just doesn't make any sense. But I know it must be objective and material. So yes, probably
that's the core problem. I mean, the core problem is that they're vested in the current status quo and everything that's gone behind it, and everything tumbles if they let this go.
Exactly. I mean, you get people like Claudio, who's not even a physicist, doesn't have a clue, couldn't read a physics paper if his life depended on it because they're mostly mathematics. And he tells you he knows. I know, he says, I know this is wrong and I know what is right. Geez, Feynman didn't even know, but Claudio knows, you see. There's a problem with that. We have people who just know it has to be, or actually don't know it has to be a certain way. They know it can't be the way it seems. It can't be that those things on the screen somehow magically change depending on what happens later. That doesn't make sense. They can't accept it, so they just don't accept it. And they don't know enough. They're not schooled in it enough to say, I don't know, like Feynman did. You see?
So does it help if you have somebody who does research this, just doesn't have all that baggage? It seems to be helpful that you can actually kind of see it a little more clearly because you just don't have all this invested, alphabet soup behind you that you need to see it a certain way. You can create any theory you want if you're already saying this is what the final result needs to be. Let's work it out. I mean, you can create anything. You can change all kinds of theories to fit what you want. If you already know what the outcome has to be, you're going to keep changing. And every time somebody comes around and says that's wrong, you're going to switch it again and you're going to change it and you can change it until which is kind of insane.
It's exactly the way it is. So there's no doubt that Claudio and others can go out and find, 100 physicists that agree with them. It couldn't possibly happen that way. Well, that's not surprising. But that doesn't make them right, you see. I mean, even that guy who was sitting there in that, I don't know if you've seen, there's a website out now that they're actually doing what you proposed. They're saying, hey, physicists, we've got a problem here. And if any of you guys would like to step up to do this kind of research, it certainly would be good. And he explains the problem, and they go through this delayed eraser, and that's good. You know, I wrote a little thing, said, way to go, guys. You know, maybe somebody will take you up on it, and they'll actually do a more conclusive experiments. But what happens then is you have these people come around and say, oh, it's impossible, can't be that way, I don't know what he's talking about. You see, because they have a belief that's contrary, and they are absolutely 100% certain that their belief must be right. And anything that disagrees with it must be wrong. But if you notice on that double slit delayed erasure experiment, in the conclusions, they say what we got, the results we got were as expected. They were exactly as calculated. Nothing here unusual happened. Okay, that's because they were using the Copenhagen interpretation, which is what quantum mechanics basically uses, because that's the one that works. That's why they use it. That's the one that gets right answers. And they calculate what happens. And all the math says, here's what's going to happen. And it did. Again, for the probably 500th time, it happened again, just like they said it would. So it's not like this experiment was a something new, and it turned up with new information never heard of before. This experiment is 80 years old, and it turned up the same information that it always turns up when it's done. No surprises there at all. Well, there's a lot of people just can't accept that, and some of those are physicists, and that's just the way the world seems to work. I just cannot spend all of my time running around trying to argue with people who don't know what they're talking about. I got enough to do without that. And you cannot argue with true believers. I mean, there's just no sense trying to tell that Jehovah's Witness when he knocks on your door that, he doesn't have his facts straight. It's unacceptable to him. You just can't do it. And it's the same with this. It just flies in the face of the belief in an objective material system. And there's plenty of scientists who just can't buy it. They know there's something wrong. Yeah, that weirdness, one day we'll understand it. And when we do, it'll be objective and it'll be material. Well, it won't. And virtual reality, guess what? As soon as you see this as a virtual probabilistic reality, the whole thing becomes perfectly clear. You know exactly why it works that way. And it's not just little things. It's everything. It's it's the big stuff in the sky. It's the stuff all around us. It's why our world is the way it is. It all works that way. When we make the measurement, we get a result that's sent to us in our data stream, and that's the result. There's nothing going on here in this virtual reality except a lot of calculations. The real action is between us, the consciousness, and the server, and the data streams going back and forth. That's the name of the game. And then it all makes perfect sense of why it has to be that way. Why would reality be this weird thing? Well, it isn't. It has to be that way. It's the only way that works. It is probabilistic in its nature. So you see that makes sense. And then when you not only explain quantum mechanics like that, it makes perfectly good logical sense. Relativity pops out, tunneling pops out, paranormal pops out, the Buddha pops out with, we're all one. I mean, all this stuff just pops out of the same thing. Well, geez, that kind of makes you think maybe you're onto something, when it kinds of answer all of these questions. So, yeah, I'm sorry if I get a little excited on you here, Mike, but I've been around this thing probably hundreds and hundreds of times.
No, I'm glad. I'm glad you got excited. I thought you'd be sickened to have to talk about this all the time, and I'm glad you convinced me that I'm not crazy. Because I went through all this stuff and I was seeing it exactly the same way, and I was trying to see these other viewpoints as hard as I possibly could. And and even their own experiments that they're citing suggest that you're correct. So, I'm just glad that you pointed it out. I'm glad you were excited and happy to talk about it. So this wasn't like, sticking thorns in you to talk about this topic again. But,
no, I get a little frustrated with it because I've answered these questions, over and over and over again, but it doesn't make any difference. True believers just won't let go. They believe what they believe, and they're sure they're right. And that's just the way it is, you know. And again, I'm not coming out of the left wing of quantum mechanics doing crazy stuff. The reason that in that paper, that delayed erasure paper, they said nothing unexpected happened. What we got is exactly what we calculated we would get. It's just the Copenhagen interpretation. It's been around since 1927. I think it was like 1920 to 1927. And that's how long it's been around. Geez, and it's proven itself in quantum mechanics experiments for 80 years. The only thing I bring to it that's different is why. Why does it work like that? It's not weird. Look, here's the way it works. That's my part to it. The fact that that experiment turned out that way, that's old news. And when you look at that experiment and you can say, well, look, time isn't the issue. It doesn't matter whether it's 10 nanoseconds or 10 years. That's not important. And it's not important how they erased the data. You see, it didn't matter. They could erase the data right at the detector. They could have turned the detector off. They could have let the detection process go on and then erase it later. It doesn't matter how the data gets erased. It matters whether or not that data exists, whether it's been erased or not erased, when somebody looks at the screen to see what the result is. Then it matters, because then the probability gets, it's a 1 or a 0, one way or the other. And the fraction pattern, you get 2 lumps of particles. So that's it. So when I do my experiment with the envelopes, I'm not doing an experiment any different than the one in that paper, than that delayed erasure. I'm doing a delayed erasure experiment. And it doesn't matter whether you get rid of the data by burning the envelope with the detector data, or whether you erase it with clever scheme of confusing it with half silvered mirrors, or whether you cut the wire from the detector, or whether you just don't receive what the detector says. Getting rid of the data is the key. It's whether or not there's data there that will cause a discontinuity in the reality. If there is, then that's a problem. So the system works so there isn't. The system was set up so that you don't have discontinuities in the reality. So that's it. So when I do that experiment with the envelopes, as far as I'm concerned, I'm just taking the delayed erasure experiment paper and putting it in different terms so that people can understand it more easily. And I haven't done anything that they haven't done. I've just done it differently. I've just rearranged it. I did the erasure different. You see, I just do it differently, but it's all the same things. I had a year, 10 years instead of 10 nanoseconds. It doesn't matter. I had a different kind of erasure process. It doesn't matter. How it gets erased isn't important. Does it exist or not? Was it erased or not? That's important. So the things that I changed in my thought experiment don't really make any difference. It's the same experiment. All right. Now people would say, well, we're not sure that this science, this double slit stuff is so weird and picky that we won't really believe that until you actually do that experiment and it works that way. Well, that's fair enough. I accept that. So I agree with the guy who put up that website and said, hey, let's do this experiment. I agree. Let's do this experiment and make it perfectly clear. Just like all the calculations said that the energy of the detector was not affecting the particle. That wasn't a consideration of the guys back in the 1920s. They knew that wasn't the case, but people still clung to it for 80 years or 70 years until these very clever folks at the University of Maryland put this touchless scheme together that showed beyond a shadow of a doubt it has nothing to do with the detector's energy, interacting with the particle. Well, you'd think that would shut up all those people that believe that. But no, lots of people will still say that. They still cling to that idea, even though there's been an experiment that says that's not true.
Well, that's what they say. What they're saying is that the reason why we're not doing that as experiment is because we already know, so there's no reason to do it. It's such a simple thing to do, but they don't want to do it because they already know. How insane of a belief system is that?
Yeah, well, that works on both sides of it. The ones that do understand it don't want to do the experiment because they know how it'll work out. It'll work out pretty much the way I say, because that's the way the Copenhagen, interpretation would have it work out. And that's been the interpretation that gives right answers now for 80 years. So, that's a good probability that it's going to work out that way. there was a good probability that when somebody came up with this clever touchless experiment, that it would be shown that the interaction of the detection process with the particle had nothing to do with it. I mean, most all the people, at Feynman's level, he knew that. He knew that that didn't have anything to do with it. But, the doubters still remain, so these clever people came up with an experiment that put an end to it. You'd think, but it didn't put an end to it. I would say that 90% of the physicists alive in the world today don't even know that experiment happened, because there's probably not more than 4 or 5% that are really quantum theorists. Physics is a very deep, broad field that has so many areas of specialization in it that just because you have a PhD in physics doesn't mean you know anything at all about any of these specialized areas. And quantum theory is a very specialized area. But everybody has an opinion just the same. Whether they know anything about it or not usually isn't the main factor in whether or not they have an opinion. They all have opinions, and if somebody comes to, hey, you're a physicist, you got a PhD, what's the answer to this? Well, that's like coming and talking to a GP who, has been a general practitioner, MD, for a long time, and ask him about some particular question of, brain surgery. Well, he doesn't know. Okay, he's a doctor, but, he doesn't know everything in medicine because it's a very complex, big field. Well, it's like that in physics. But yet, if you go ask an MD about something about how the brain works, he'll tell you whether he knows or not because he's an MD and he feels like he ought to give you an answer. Well, it's the same way it is with physicists. You ask a physicist and you say, hey, you're a physicist, tell me how this works. Well, they'll tell you what they think, how it works, but it's just as likely to be nonsense as not.
Well, I'm glad that I was able to get you all pumped up and excited to talk about this. This is very, very special. So I don't want to take up anybody else's time, but
yeah, I just wish that, I didn't have to keep doing this over and over and over and over again. But so I'm not doing anything too amazing. I'm doing the same old Copenhagen thing that everybody else does. I just come up with how does it work? Take the mystery out of it. So that's it.
Thank you, Tom.
Well, thank you, Mike, and thank you, Tom. That's the most fun I've had with the double slit experiment in a long time.